Welcome, everybody. We are going to work on the Unit 5 exercises, which cover Chapter 6 in our book. There is a document that's attached to the assignment that you want to pull down in order to get like the query prompts. So like there are, I think, 6 exercises here, 5 exercises, so not a lot. But there's a lot of like learning materials that goes with these, right? So we are going to be using the classic models database. So if you haven't done so already, launch your coding environment. So I'm using MySQL Workbench, right, which I assume most of you are doing as well. And then I'm going to connect to my local instance of MySQL. And then I want to go ahead and I want to close. Actually, that file I can keep open. That one's going to be just fine. All right, so if you notice that our first directive here is to use the classic models MySQL database. So for my students, that's a database that you guys already should have loaded up as a schema inside of MySQL Workbench. If not, you're going to have to attach to it. So you can see for me up here, it's listed, right? And I can see I have all my tables. I'm just going to do a refresh here just to make sure that they're all loading up. And if I want to just, for example, make sure there's some data in there, I can click on one of the little icons there and just make it show up. All right. So my first SQL command then, just to be sure that we're issuing our other SQL commands on the correct database, is just going to be a regular old use statement. The database, of course, is called classic models. So I'm just going to go ahead and execute that statement. And now we are in principle attached to that database. So all subsequent queries will happen against that. Now we are going to do these queries one at a time here. And just to save myself the trouble of bopping back and forth all the time, I'm going to put the instructions here. And then I'm going to put a double dash in front of it. And by the way, that's one way to make it a comment inside of SQL. You can see it doesn't like it though, right? What's the correct way to do a comment in MySQL?
Slash asterisk, I think.
Yeah. And George, you're thinking of the CSS style approach, right? Which is like
Yeah.
this. And that's one of the preferred ways to do it. So actually the dash approach works as well, but it doesn't seem to comment out in here. It depends on which engine you're working with. But hey, if this one likes this approach better, let's use this one. Can anybody else think of a different approach? All right. Here's what professionals do when they don't know. They Google it, right? And I'm just trying to, and I know this sounds like silly, right? But there are
Right is a moral or legal entitlement to do or have something.
Okay.
It's a power or privilege that.
All right, sorry. When I say the right words in sequence, my Google like AI on my phone kicks in and automatically answers my questions. So I must have used the right keyword sequence. Sorry about that, Google. But yeah, there's different types that we can use, and this is really kind of the bizarre thing. But just remember, you can always Google it if you're not sure. The style that we're using is what we call the CSS style, which is the slash star star slash, right, with the stars on the insides of the slashes, basically. I just see that Jared put in the chat here too that we could also use, for example, slash slash, right? But is it really turning into a comment? And you know what, Jared, you're right. I did say Google it, which is why. The other one that's really common in a lot of languages is the pound sign, by the way. So for Python people, right? So I know I have a lot of you in the Python class. These two techniques work in Python also. Isn't that fascinating? So the CSS style or the pound sign. Those are probably the two preferred approaches, generally speaking. This one allows you to do multi-line comments, right? So I can basically move this down and type a bunch of nonsense here, and I will ignore everything in between. Where this one is useful if I'm actually typing a command, right? And I'm using keywords here, whatever. And then it will basically ignore whatever comes after it. So I can put it on the same line with my code. So that's kind of, the same thing applies in Python, by the way. So you can use either approach. All right, I think that's enough of an example of that, maybe taking it a little too far even, but that's okay. Whatever approach you use does not matter as long as that question doesn't execute as SQL code. All right, so we've already attached to the database. Now we need to write that first query. It says create a query with a count of all the customers grouped by country. Okay, this is an interesting ask here, because now we have to consider a couple of different things. First of all, what table does this come from, right? So this is going to lead me into like a little bit of a micro lecture on this. And I'm doing this mostly to kind of demonstrate a feature. We'll talk about it more when we learn how to do database design. But there is a tool in here, and I'm trying to remember what menu it's under. All right, it's under the database menu. And you'll notice that one of the entries on this menu says reverse engineer. Fascinating, right? That they would give us that as a menu option. But here's what that command does. I'm going to go ahead and I'm going to reverse engineer this database. And it's going to basically ask me to set some parameters. I'm just kind of going with defaults on this, by the way. And I'm just following through. Now, which database am I working on? I'm working on classic models. I'm going to click next, next, and execute. And then what this does is it creates one of these. All right. So this is called an entity relationship diagram. It shows a visual of all the tables in the database and their column names and how all the tables connect. So this is super, super useful. This is kind of like, if you want to do a comparison here, I would actually call this the blueprint for the database, right? What is the structure that we're using for this database? It's shown right here. It shows every column, every table, every data type, every connection, what table goes to what table, and et cetera. It's all here on this particular screen, which I think is very, very helpful. Okay, so why is this useful to us? Well, I was asked the question, and the question was, where am I getting this information from? So what was the question again? Well, let's go to the Word document. It was create a query with a count of all the customers grouped by country. All right, so where do I find this information? And this is where you start looking, well, you know what? We're dealing with customers. So maybe the customers table, I'm just guessing, right? And of course that is the answer. But if you didn't know that answer, this would be like hugely helpful if you're looking for very particular pieces of information. So you might work, let's say, if you're working as a professional database person, you're asked to do something like this, and you don't know the data structure. Well, how do you figure it out? This is why this command is helpful and why having the diagram is really helpful. So, I mean, I think that we can pretty quickly figure out this is going to come from the customers table. And in the customers table, we can see all the different data fields and all the stuff that goes with it. All right. So I'm going to go ahead and close this diagram, but I just want to show you that is there basically as a tool that you can use at any time, right? And I know that you also have that information at your fingertips here, so don't forget that. For example, I can click on each one of these tables here and it tells me what's in them. And maybe that's a simpler tool for you. But if you were working with tables that are connected, how would you really see the connections? That's really kind of the better answer. All right, so let's go ahead and start building the select statement. So I'm going to start using some of the basics here. So we'll start with select, and I'm going to say, well, what do we ask to select? We want a count of all the customers grouped by country. So inside here, we're going to say count, and then we want all the customers. So what would be a good field in the customer table to help us determine how many customers we have? Could I suggest maybe the customer number might be a good one, right? So I'm going to use that because every customer has an ID, and that's our primary key, by the way, for that table. You know that because this is highlighted, bold, and underlined. That means it's a primary key. So that's a good one to use to do a count, right? I'm going to give this an alias. So I'm going to say as, how about something like this, number of customers. That's a nice alias, I think. The other column that we need is what? Country, right? So we have to choose the country, which is also, well, is it part of this table or is it not? Where would I find that? Yeah, I would just simply highlight the customers table. I can look at the information here, and I do have a country field. It looks like it's a varchar 15 or 50 or whatever. Okay, so we're pulling those two columns. All right. What table are we pulling them from? Well, I guess we already figured that out, right? So we're pulling it from the customers table. All right. They're telling us what to group it by. So that part's easy. So I'm just going to say group by country. That's pretty simplistic. All right. Are we asked to order it in any way? No, we're not. You know what? Can we run this and just see what it does? Let's do that. So I'm going to run the query. Here's the output. Right, and you can see the table is fairly large here. Right now, when it comes to when you guys are like screenshotting the output of this stuff, you don't have to show me the entire table. Like showing me the top part of it is helpful, unless the bottom part of the table has pertinent information. Now I'm looking at this data, and you know what? I see that there's kind of like, well, the USA's got 36, and I got Poland that's only got 1. Would it make sense to order it? I think it would, right? And so I'm going to do that, and I'm going to call this step optional, but I would hope, ideally, that you would see it this way too, right? It'd be helpful to have some sort of a hierarchy. So I'm going to order by the count of the customer number. And I'm going to go descending, kind of like we saw in that example. I want the one with the most at the top, not the one with the least at the top. So I'm going to run that query again. And there you go. So now we're qualified. So we have USA at the top. And if I scroll down, I end up with countries that only have 1 at the bottom. So I think that's a more useful output. All right. So there's the first exercise complete. You guys all good? All right. Let's move on to the second exercise, which is this. And so I'm going to paste this in here. Oops. Let's put in our pound sign. So create a query with a count of each of the product lines. All right, let's take a look at some of the products. Okay, well, it's not there because it's part of a product line. So let's go look at product lines as a table. You know what? And let's actually take a look at the table and see what's in there. So it has a bunch of text in each area. It's a pretty large amount of text, right? So it's a description, right? Full on description here. So the product lines are cars, cycles, planes, ships, trains, trucks, and buses, and vintage cars. Those are the categories, and there's a description that goes with each one. So what we're asked to do once again is create a query with a count of each of the product lines. Okay. So we'll think about this a little bit. So counting the product line is one thing, right? And could I just look at it? I mean, yeah, that's one thing that you should say to yourself. Yeah, I could just look at it. And now do I have a count right here? I could just go 1, 2, 3, 4, 5, 6, 7. Great. But we're not on Amazon.com, right? So our website's really simple. We got 7 product lines. But what if I was Amazon? And I'm like, how many product lines do we have? Okay, well, there's a question, right? That's a query that would have a huge result. Like, who knows what they have in terms of product lines. Okay, so let's go back and write our query now with that in mind. All right, so we're going to select, and once again, we're going to do a count. So we're going to say count the product line. So I'm looking here because that's our primary key, counting the product line. You got to spell it right though, so count. There we go. I'm going to create an alias for this. So I'm just going to say as, and I'm going to follow what I did before. I'm going to say number of product lines. You could skip this step if you wish, not a big deal, but I think it's helpful to say something meaningful, right? We're also going to add to it the product line itself, right? Now you notice this is kind of an interesting table, the product lines, because when I look at the data on it, I'm just, going back. I guess I already had it open. But notice that the primary key on this one is text. It doesn't have a number, but it's still the primary key. Is that okay? Yeah, that is okay, by the way. As long as these are all unique, that's absolutely fine. All right. So we're choosing the product line from which table? Okay. So we're thinking that it's the product lines table, but really, does it make more sense to choose it from here? Right. I think so, right? So we're going to count how many unique product lines there are in the products table relative to the product line. All right, so we are going to grab that from the products table, actually. And then we'll do some grouping here. Let's group by the product line. And once again, I'm going to run the query without any ordering and see what we get. So this is the same list, correct? But notice, because we're running the count function, we're also getting a count of how many of those are in each category. See the power of this query? That's pretty helpful. It really is. If I were to take it up a notch, what I would do on this one is I would order by, and I would basically just reiterate this command, right? So I would add that here. And I would do it descending. I want the biggest category to list first. So if I run that, now it goes in that direction. So classic cars, vintage cars, motorcycles, and then it moves on down. Apparently not a lot of train collectors, right? All right, so there's the answer for number 2, both the code and the output, right? So that one's pretty easy to capture. Maybe even do it with one screenshot. Assuming you guys are all good, I'm going to move on to the next one. All right, so here's the next directive here. This is number 3. And you know what? That's kind of getting long there. So let's just make it do that. So create a query that calculates the average payment amount by customer having an average payment greater than 10,000. And I think that syntax. It's just all in the reading. The syntax is actually fine. Here I'm looking to fix my English, right? All right. So once again, we have to figure out where the payments are stored. Well, there is a table called payments. We can take a really quick look at it and notice that we can pull, we can tell which customer made the payment, right, by the customer number. And then we can also take a look at the amounts, right? So those are available in that table. Does that help us here? Calculates the average payment amount by customer. Okay, so in other words, I have to find the customers first, get the average from that customer, and then display that as long as it's greater than 10,000. See the challenge on this one? Yeah, it's a little bit deeper. All right. So first, we're going to have to pull that key piece of information which identifies the customer. That's the customer number, right? So I'm going to do a select. I'm going to say select customer number. Then they want us to do the average. So I'm just going to kind of like type that in really quick, and then I'm going to ramp it up, by the way, which is, what are we averaging? We're averaging the amount of the payment. So here's the declaration for that. So if you notice, there is an amount listed right here, right? So that's what we're pulling from. However, this is money. We're doing math with it, right? I'm also noticing that right away that the amount, if you look really closely at this information, it's a decimal number that's 10 digits with 2 after the decimal point, right? So if we divide into that, we could get a fractional portion smaller than that. So we'll need to round that. So we're going to wrap the average function with a round function around it and add the number 2 like this. So we will say round, right? And maybe I should make that one uppercase just so you can see it a little bit better. But so we're taking the average and then we're rounding it. So that's the order in which those operations happen, by the way. This is very powerful. We're doing 2 things in one step, really. And we're going to like take this rounding and we're going to alias it. We're going to say as AVG payment or something like that. Customer number, average payment. Where are we pulling this from? This is coming from the payments table. And then we're going to do some grouping. So let's try the grouping again. So we're going to group by right. So we're going to order these, or not order them, but pull them together by the customer number. The other thing that we have to consider here is now they want only the ones that are greater than 10,000. Now, this normally would be a where clause, right? However, I'm going to be looking at the average. So I want to look for averages that are greater than 10,000, meaning I can't use where, I have to use having. So this is kind of that first example of this. So we're going to take the average of the amount where it's greater than 10,000. Okay. And let's just go ahead and order it right away. We're going to average it by, or order it by average. And I want to use the syntax I used above, right? The same naming. So we're going to use the alias here to order it, like so. I think I'm ready to run it. So here comes the run. All right, so there's our customer numbers. Notice the average payment. And notice, because I did not order it descending, right? We just let it order naturally ascending. The numbers, it starts with the smallest average payment and it goes to the largest. It is qualified by customer, so we're not like necessarily identifying the customer, but we could, right? So if we join tables, we could pull that information into. That's not what was being asked, though. Right, so there's an example of number 3. You guys good? So far, so good. If you do have a problem, let me know so we can help you out. All right, moving on to number 4. This one says, create a query that totals all the payment amounts by customer. So in other words, for each customer, I want a total. That's not an unreasonable ask, right? So let's do the same thing here. And there's going to be some commonalities with what we just did and some differences too, right? Are we pulling it from the same table? Yeah, we totally are. And we're going to start the same way. So we're going to select the customer number. This time we want the sum, right? So I'm going to put in sum. I'm going to follow the same approach I did last time. And this time we're taking the sum of the amount. And once again, not that this would necessarily break, but hey, you know what? It's probably a smart idea to round it to 2 decimal places just in case. Here's the why. What if it's all round dollar amounts, but we still want to show the .00? That's one example as to why. Unless one of those purchases has fractional pennies in it, which I don't think it would. This just helps make sure that our output honestly looks good. I'm going to do a little aliasing on this. And once again, what should we call this? Total payments. I'm just trying to think here. Yeah. So I'll just call it total payments. I'm not putting quotes around it because I'm not using spaces. All right. Where are we pulling this from? From the payments table. And we want to look at the totals by customer, which means we're grouping by a customer number. This one almost seems too simple. There's not a lot of code on this one, right? Right, let's go ahead and run this query. All right, here's the outputs that I'm getting. So notice we're not ordered by anything. So I could order it by customer number. I could order it by the total, the sending. In fact, that seems like kind of like a logical one, right? So I could order by total payments descending. So I'm not sure why I always do that one all caps, because otherwise I think I don't see it. Maybe is why. All right, let's run that again. And so now it's in the order of the biggest payment, total payments, to the smallest. So this would be a way of basically saying which customer has given us the most business over time. That's really what that's saying. That could be very helpful for sure. Right. That's exercise number 4, folks. We got one exercise left, and how do you like that? We're going to finish kind of early. I think that's a first for us, right? Totally. Do I have any complainers? Not a one. All right, here's our fifth exercise here, which is to create a query that displays the total number of orders and their sum. All right, now this one is going to take a little bit more thinking. So I thought and I'm going to do a different technique here than I normally do in class. And this is part of the reason uh, we have a little extra time tonight. This is actually by design, if you guys thought you were cutting out of here early. What I'd like to do is rather than me engineer this query and have you guys copy paste, what I'm going to do is I'm going to gather you guys up and randomly put you in breakout groups. And I know you guys hate this stuff, right? Is there anybody here that's opposed to working in a small group here? It's okay to be honest. Jonathan, you're opposed? Okay. Anybody else opposed? All right.
I've had my experiences in the past where I've been in group things and there's one person in the group that did no work and the teacher gave the entire group a F because of it, and ever since then I despise group work.
Okay. Well, I feel your pain, but let me just tell you that when you go out into the real workplace, right, and you're on a team or something, and sometimes you run into people exactly like that, unfortunately, right? So I feel your pain. My goal here would be to get you guys to talk to each other. How about this? Let's try a different approach. And maybe instead of putting you into small groups, because I have, I don't know, seven people, cameras off, mics muted, and rarely unmute, right? And that's kind of a norm for those people. And I don't want to make those people feel on the spot. I'm not saying people that are muted are not engaged. I know differently. But I think they're more apt to be unengaged, if that's even a word. So here's kind of and I know that I'm recording all this, which is kind of weird. I am going to pause the video right here. All right, so I had people work on this on their own for a little bit, and we came back and one student shared two possible solutions. One where he queried directly from one table, I think the orders table, if I remember correctly, Brent. And then the other approach where you actually did a join on the tables and then ran your query, right? Both interesting and possibly valid approaches. And I'm not giving it all away right away, but this is the approach that I took. So the first thing that I thought about was, all right, well, kind of the same solution approach, right? So we're going to do a count here for sure. That's a kind of a given. And it's a matter of like what we're counting. And the logical thing is the order number, but where are we grabbing that from? And then I started thinking to myself, well, we might have to grab
Yeah, your screen's not shared.
Oh, wonderful. And now my big face is on the internet. So let's that. You guys think that's funny? Just wait. Someday it'll be
A little bit.
All right. Well, whoever's speaking up right now, your face is on the internet too.
Awesome.
So sometimes it pays to be muted. But okay. So once again, I realize I'm going to have to select based on a count ultimately, but I am going to grab from the orders table and I'm going to alias that as the letter O. So that will be my prefix. And I'm also going to grab from the order details table, which I'm going to designate as OD, right? So those are the prefixes I'm going to use up here. So here, I'm actually going to pull it from the order details table. I'm going to pull the order, lowercase here, order number. So how do I know that? Because I can look in here and I can look, right? Order number, right? So I'm going to get the count of the order numbers. I'm going to alias it as total num orders or something like that. You know, you can make it even prettier if you wish. That makes sense to me though. The other piece that we need is the sum, right? And so once again, I'm going to pull the sum. You see, I'm typing it uppercase, and you know, I'm not great about following formal syntax where it should be all uppercase, but whatever. Also from the order details table, I'm going to look at the price each. This is kind of a weird one to look at because if I summarize the price of each thing, it should give me the total price. And I'm going to call this price total, right? The total number of orders and their sum. Okay, that's really the ask here. It's coming from both of these tables. And then we have a criteria. Now I can use where. Why can I use where? Because I'm not using a function. That's the why. And the criteria is where the order number from the orders table, that's the single O, equals the order details order number. All right, now we're curious here. Will this give us the same results that Brent got? And Brent, was that the second one or the first one? I think it was the second one, if I was not mistaken. Let's see if it comes up with the same number. So I'm going to go ahead and execute this query. And notice the values. Are these the same numbers that you got? And Brent, if you said something, I didn't hear it, but you could drop it in the chat too. Okay. And Elizabeth is saying yes on your behalf. So I don't know what happened to your mic, Brent. Maybe you hardware muted it or something. But
Is it working now?
Yeah. Yep.
Yeah. That was right on my second attempt. That was different from the join one though.
All right. And could you do me a favor and put what you used as a query in the chat, and then I'll drop it up on screen here to show everybody. Then we can talk about why they both worked. All right, so this was, and I'm going to mark it here, Brent's solution. Still counting the order numbers. He's just getting it from the order details table, and he's pulling the sum, which also comes from the order details table. What is the advantage of doing this? Is there even an advantage? Is kind of the question you ask. We got the same exact numbers. Now this, and folks, what's really cool about this is a logic issue entirely. We're getting both of the same answers. Certainly one of them is a little bit cleaner than the others. We're not joining tables, not necessary. Really all the information exists in one table. So Brent, I'm going to say very astute to pull it all from one spot without having to match up the order numbers. If we had additional criteria in the problem solution that specified that the order had to exist in the orders table in order for you to summarize it, then this would be pertinent, but certainly not necessary. So I'd say either one of these answers would work for me. It's not how I thought about it in my brain when I wrote my version, though. Right? I would say that I maybe overthought it. And Jared made a really good point in the chat, like what makes like one query really better than another, and what Jared said is data compression ? And it's not really data compression, but if you have a simpler query that's only pulling information from one table, that's one less spot to look for the information. So the second query would run faster if that's all the information we need and it's accurate. So that would really be preferred. This one would also reach into the other table because it's got another command to complete and it's looking at another set of data. So it would take longer to process. Not noticeable with 20 records. 10,000, you would see a big processing difference. 100,000, humongous. Right? These are goofy little things that database administrators and operators think about a lot when they're concocting queries. Yeah, well, true. it would contribute to a smaller file size in terms of the query file, Jared, but it doesn't necessarily change the speed at which it operates, right? So the query can be very verbose, but if it's efficiently structured, this approach uses two tables. This approach just uses one and comes up with the same answer. The second one is a better answer. All right, I'm going to stop the video here, folks. If I can find the stop button. Pretty sad that I can't find it.